Hi everyone. Today we're going to study integer exponents. An exponent is a small number placed on upper right hand of another number or variable that tells into how many times the number is to be multiplied by itself. One example is here, x raised to n. In here, the small number n is what we call the exponent. The x is what we call the base. So let's have an example. So this is 5 raised to 2. But for exponent 2, there is a special name for that, and we read it as square. So this example is read as 5 square. So the 5 is the base, and the 5 is multiplied 2 times by itself. So this is 5 times 5 equals 25. Another example is 2 raised to 3. For exponent 3, there is a special name for this, and it is read as cube. So this example here is read as 2 cube. So the base 2 is multiplied 3 times to itself. 2 times 2 times 2 equals 8. Now let us go to the laws of exponents. Let us begin with the first one. The first law says we're going to multiply exponents with the same base. So in this case, we're going to add the exponents and we copy that same base. X raised to m times x raised to n equals x raised to the sum of m and n. Thus, m plus n. So we have example here, x raised to 5 times x squared equals x raised to the sum of 5 and 2 equals x raised to 7. Another example is a squared times a cube. We see here that the a has no exponent, but if a variable has no exponent, it is understood to have an exponent of 1. So we see here a is copied as the base and all exponents are added here. 2 plus 1 plus 3 equals 6. So the final answer is a raised to 6. Let's have the second law. It says we're going to divide exponent with the same base. We simply subtract the exponents. But take note that the exponent on top should come first. So this is m minus n. Let's have example. Y raised to 7 divided by y raised to 5. So this is equal to y 7 minus 5 equals y squared. Another example, b raised to 9 over b raised to 8 equals b raised to the difference of 9 and 8. 9 minus 8 equals b raised to 1. In case of exponent 1, we can remove that exponent. We can simply write b. The third law is like there is an exponent inside the grouping symbol and there is an exponent outside. So we can simplify this by simply taking the product of the exponent. By the way, exponent is sometimes called power. So we can say that we are multiplying the powers here. So let's have an example. The x raised to 5 is again raised to power 2 outside. So we're going to multiply the exponent 5 and the 2. The final answer is x raised to 10. Another example, p raised to 4. Again, this quantity is raised to power 3. So p raised to the product of 4 and 3. Final answer is p raised to 12. The fourth power is the power of a product. So there is a product inside, there is an exponent outside. So this is equal to the exponent outside is distributed to each of the terms inside, each of the variable. So this is x raised to m times y raised to m. So we have an example here. The 3x is raised to 2. So the power 2 is distributed to the 3 and also to the x, as we see here. 3 square times x square. So we can simplify the number. The 3 square becomes 9. X square we copy here. So the final answer, 9x square. Another example is the quantity 5x raised to 5 y square are all raised to power 3. So we're going to distribute the 3 to all the terms inside. So the power 3 is given to the base 5. The power 3 is distributed to x power 5. Also the exponent 3 is distributed to the term y square. And then we will simplify. So 125 here, it becomes x raised to 15, and this one here becomes y raised to 6. So the final answer, 125 x raised to 15, y raised to 6. When we have a quotient that is raised to a power m, so this is equal to the power m is distributed to the x and also to the y, as we see here. X raised to m over y raised to m. Let's have the first example. X over 2 is raised to power 3. So the power 3 is distributed to the x and to the 2, as we see here, x cubed over 2 cubed. So we can have more simplification to the 2 cubed becomes 8. So the final answer, x cubed over 8. So the power 2 is distributed to the 5b, also to the y becomes y square. So the 5b, we can still simplify this. So distributing the power 2 to the 5 and also to b becomes like this. And we reach the final answer to be 25. We simplify 5 square to be 25, and the b square is here all over y square. So this is our final answer. The sixth law is about zero exponent. So this law says any number or any variable raised to 0 is equal to 1. We have first example, 5 raised to 0. Directly we can put 1 as the answer. So this is equal to 1. The second example is the quantity x squared plus 1 are all raised to 0. So this polynomial here, because of the 0 power outside, everything is boiled down to 1. The seventh law for this video is when we have a negative exponent. So this law says if there is a negative exponent like this, minus m, we can simplify or we can rationalize the minus. We get the reciprocal of this variable x. So again, x raised to negative m is equal to 1 over x raised to positive m. Let's have example. 5 raised to negative 2. At first, we can remove the negative sign by doing like this. We are going to put 1 over 5 and the exponent 2 becomes positive. So this is now 1 over 5 square. And we can simplify the 5 square. So the final answer is 1 over 25. Another example is when we have a fraction 10 over x and this is raised to a negative 3. For a fraction, we can make this negative to be positive by simply interchanging the position or reversing the position of the numerator and denominator. As we see here, the x goes up, the 10 comes down as denominator, and look at the power. It becomes positive. And then we can now apply the distribution of this power to the terms inside. So it becomes x3 or x cubed over 10 cubed. We can still simplify the 10 cubed. And the final answer is x cubed over 1000. Let's have more examples. Some problems require application of more laws of exponents before they reach their final answer. Let's consider the example 1. Simplify this expression. As we can see here, there is a grouping symbol and inside there is a fraction. The numerator is x raised to negative 3. In the denominator, there is a product of y raised to 4 and y raised to negative 4. And outside the grouping symbol, there is a negative 3 power. So what we will do, first, we are going to simplify this denominator. As we can see, the y raised to 4 and the y raised to negative 4 can be combined together. We can show that this is y raised to 4 minus 4. And then, the 4 minus 4 becomes 0. So the y here now has a power of 0. Then we will simplify that y raised to 0 into 1. Next is the x raised to negative 3. We want to rationalize that negative 3 sign. So what we will do, we're going to flip this fraction. As you see here, the 1 becomes the numerator, the x power 3 becomes the denominator. But please observe, the exponent of 3 here now is positive. So before it is x raised to negative 3 over 1, now it is 1 over x raised to 3. Next is, we have a negative 3 outside of the grouping symbol as exponent. So we need to rationalize the negative 3. What we're going to do, again, we're going to flip this fraction inside. So the x cubed goes to the numerator again over 1. So look at our exponent 3. It becomes positive now. And then we are now to distribute this exponent 3 into the numerator and in the denominator. So we have the x cubed all raised to 3 and then the 1 raised to 3. X cubed raised to 3 becomes x raised to 9 and then this 1 cube is simply 1, so we can put here over 1. With that denominator of 1, there is no need to write. So our final answer is x raised to 9. Let's have this example 2. Here there is a fraction multiplied by a monomial here. In the fraction, our numerator is 6x cubed all raised to 2. In the denominator, inside the grouping symbol is 2x squared and all raised to 3. And this monomial here is 3x squared all raised to 0. For the next step, in the numerator of the fraction, the power 2 will be distributed to the 6 and to the x cube. As you see here, the 6 is now squared, the x cube is also squared. In the denominator, the power 3 is distributed to number 2 and also to the x squared. And as you see here, 2 with power 3, the x squared with power 3. For this term with all raised to 0, this 3x squared is now consumed into a value equal to 1. And then we're going to simplify the terms in the numerator and in the denominator. So the 6 squared becomes 36. This x cubed raised to 2 becomes x raised to 6 all over. The 2 cubed is now 8. And this x squared raised to 3 becomes x raised to 6. Next is, we're going to factor out the 36 and also the 8. And we can see that if we factor out the 36, it becomes 4 times 9, and the 8 becomes 4 times 2. And we can see a common number here, 4 and 4. Then later on, we can cancel that. For the x, we can combine this x raised to 6 and the x raised to 6. We can write x raised to 6 minus 6. And then, for the numerical coefficient, it's now 9 over 2. And then the x with power 0. But we know that any variable with exponent 0 is equal to 1. We just copy the numerical coefficient, 9 over 2 times 1. So the final answer is 9 over 2. Let's have example 3. So x minus x raised to negative 1 all over 1 minus x raised to negative 2. Since we see here it is negative, we want to make it positive. Down here there's also a negative exponent. Both of this negative exponent we will rationalize. So the x raised to negative 1 becomes 1 over x raised to 1. Now becomes positive. This x raised to negative 2 now becomes 1 over x squared. And the exponent 2 is now positive. So with that exponent 1 in the x, we will remove that exponent 1. It is understood that there is an exponent 1 there. Next is we're going to apply the crisscross method for the numerator and in the denominator. If you're not familiar with the crisscross method, you can see the video of our addition or subtraction of unlike fractions. We can show now that the x with denominator 1 and also this one with denominator 1. So we will begin with our numerator using the crisscross method. This is what we will do. The x and the x down here diagonally, we will multiply. So x times x, we will get the x squared. We're going to write here x squared. And then we will copy this negative sign. The next is this one multiplied by the 1 diagonally. So the answer is 1. We will write the answer here. And then I'm going to multiply the 1 with the x, both denominators. 1 times x is x. Let's go now to the denominator. In here, we're going to use also the crisscross method. First, I'm going to multiply 1 by the x square in a diagonal direction. 1 times x square is x square. And then minus, because that is minus, I will copy here minus. Then 1 times 1 also, going to the direction of diagonal. So the answer is 1 also. So I'll write the 1 here. Next is, I'm going to multiply the denominators. 1 times x square. The answer is x square, and I will write the answer down here. The next is, I want to show this complex fraction like this. I took all the numerator, I will write here, then I will write the division symbol followed by this denominator. As you see, this is x squared minus 1 over x is now copied here, then divided by this denominator, x squared minus 1 over x squared is now here. The first fraction we will simply copy, and the second fraction we're going to flip such that the x squared down here becomes the numerator now, and then the x squared minus 1 is the denominator. And from here, we will cancel terms that we can cancel. First, we can cancel the x squared minus 1 and also the x squared minus 1. The next is, this is x and this is x squared. We can cancel the whole x here, and we will cancel 1 of the exponent. So the power 2 here becomes power 1. So the final answer is x. Thank you for watching the video. See you again next time.